Assalamu alaikum wa rahmatullahi wa barakatuh. This is Nazar Ibrahim and the channel Teaching by SM. As you all know, these videos are made. The one aim of these videos is that for the first 6 months of the funding which will be generated will be donated to the Palestinian people. So I would suggest all of the viewers who are seeing these videos to kindly support our cause. We are discussing basically mathematics 0580 mathematics probability chapter and we will be doing past paper questions starting from you can see that 2021, right? Okay, question number 1, the probability that Jane wins the game is 7 upon 10, right? Find the probability that Jane does not win the game. So when we know the probability of an event, if we want to find out the probability of not occurring of that event, we just subtract it by 1, right? So of not occurring an event is 1 minus 7 upon 10, which is equals to 3 upon 10. Clear? Jane plays this game 50 times. How many times? 50 times. Find the number of times she is expected to win the game. Now we know what probability of winning the game is, that is 7 upon 10, right? So 7 upon 10 multiplied by amount of times he is playing that game, that is 50. So 7 upon 10 multiplied by 50 is 10 ones are 10, 10 fives are 50 and 7 fives are 35. Clear? Okay, question number 18. In question number 18 we can see Malik goes to shop every day to buy bread. On any day, the probability that Malik goes to the shop in the morning is 0.7. If he goes in the morning, the probability that there is bread for Malik to buy is 0.95. So you see there are two cases. One is he is going in morning or he is going later. He is getting the bread in the morning, that is 0.95. There will be a case that he is not getting the bread in the morning. He is getting it later, that is another case. So starting with tree diagram, when we have more than two cases, we draw tree diagram. Now see what tree diagram is. One is buying a bread, so bread in the morning and later. So morning probability is 0.7. So 1 minus 0.7 is 0.3. If he is going later, the probability is 0.3. The total of the probability in any branch is 1. Right? So 0.7 plus 0.3 is equals to 1. When he is going in morning, he is getting the bread to buy. And if he goes in the morning, the probability that there is bread for Malik to buy is 0.95. Right? And definitely there will be a case if he goes in morning and he doesn't get a bread. So getting bread does not get bread, right? So getting bread is 0.95 and not getting a bread is 0.05, right? Okay, now here we have later when he's going. So when he's going later, he is getting bread, that is 0.6, right? Getting bread, not getting bread, does not get bread. I'm denoting it by DGB. That doesn't matter. You denote by anything you want to. So 0.6 for getting a bread, and if he is going and he's not getting a bread later, so 0.41 minus. Okay, now calculate the probability that on any day there's a bread for Malik to buy. On any day. So there are two cases. If he is going in morning and getting a bread, if he is going later and getting a bread. So two different cases, morning and getting bread probability or later and getting bread probability. So when we have and, we multiply. For morning is 0.7, for getting bread is 0.95, right? And later or this case is later we have the probability is 0.6, right? This probability 0.6 into 0.3. 0.3 is later, and into getting bread is 0.6. So solving this, 0.7 into 0.95, we have 0.7 into 0.95 is 0.665, and 0.3 into 0.6 is 0.18. Adding both, right, 0.665 into plus 0.18 is 0.845. Clear? Okay, question number 19. Carrie has five white flowers, x red flowers, 2x plus 1 yellow flowers. She picks a flower at random. The probability that it is white is 1/12. Find the probability that it is yellow. Here, if I want to find out that it is yellow, I know how many. I don't know about how many in total yellow flowers are, and I don't know the total number of flowers as well. So using this information that the probability it is white is 1/12, we know how many white flowers are there. We can use it to take out the total number of flowers, right? That is probability of white is 1/12, and how many white flowers are there? 5. And how many in total are there? In total we have 5 plus x plus 2x plus 1. Okay, so 5 upon 5 plus 1 6, 2x plus x is 3x is equals to 1/12. 12 into 5 is 60. 6 in plus 3x into 1 is 6 plus 3x. So 60 minus 6 is 54 is equals to 3x, and x is equals to 54 upon 3, which is equals to 18. So this is basically the number of red flowers, x. If I want to find out how many yellow flowers are there, so 2x plus 1 means 2 into 18 plus 1, 36 plus 1, which is equals to 37. 37 flowers are yellow, basically 2x plus 1. Okay, now using this information, probability of yellow flower is, total number of yellow flowers are 37 and total number of flowers are, I want to know this as well. So here I have 5 white and x is 18 red flowers, and 37 that is yellow flowers. 37 plus 18 is 55. 55 plus 5 is 60, right? Am I clear? Okay, so 37 upon 60 is the probability of getting a yellow flower. Okay, question number 20. Some cards have either a square, a circle, a triangle drawn on them. Pitt chooses one of the 4 cards at random. Complete the table, show the probability of choosing a card with each shape. We know that the total probability in summing all probabilities in a case is equals to 1. So 0.2 plus 0.32 plus x is equals to 1. 0.2 plus 0.32 is 0.52 plus x is equals to 1. So x is equals to 1 minus 0.52, which is equals to 0.48. Clear? Okay, moving to question number 21. We have the Venn diagram shows the number of students in a class of 40 who study physics, mathematics and geography. We have 3 cases, right? Physics, mathematics and geography. Use set notation to describe the shaded region. Now when we are doing sets, this is a sets question, came in probability together. So we have this P set which is unshaded. So it means that P complement is the first part which should be there. Secondly, we can see M and G both are shaded. So M, and with M we have union, because M will union G total, right? And since we can see that when we want to shade, we choose arrows, right? P intersection means except P all, that is this part, this part, this part and this part. And M union G means this part, this part, this part, this part, and this, okay, and this part and this part. So since we are using shading those regions which have double arrows, right? We have the shaded portion we can see that that are double arrowed, that is this part, and this part. So we will put intersection, right? If these parts would have been shaded, so we would have used union. Is it clear? So the answer is P complement intersection M union G. Okay, find the number. This n denotes the number of elements in this whole set, right? So first I need to find out the shaded region, then we can sum all the elements which are included in this given set. Okay, so first I will use the same arrow way, that is easier for the students to understand as well. M complement means except M, all the things, right? So except M is this part, this part, this part, and this part. This is M complement. Now P intersection G. P intersection G means P and G intersection means this part and this part. Now since we have in between these two combinations we have a union. Union means shade all. It means that I have to shade this part, this part, this part, this part, and this part, right? And the shaded portion, what I have, 4, I guess this is 9, 4, 9, 3, and there's 6. So adding all these up, 4 plus 3 plus 9 plus 6. 9 plus 6, 15, 15 plus 3, 18, 18 plus 4, 22. So the number of elements in P intersection G union M complement is 22. 6, 9 plus 6, 15, 15 plus 3, 18, and 18 plus 4 is 22. Clear? Okay, now done this, now we are on this. A student is chosen at random from those studying geography. Find the probability that the student also studies physics or mathematics. Now choosing from the students who study geography, it means that we are just choosing from this side. And how many elements are here in total? 5 plus 9, 14, 14 plus 6, 20, 20 plus 3, 23. So in total geography students are 23. From the probability that the student also studies physics or mathematics. So physics, geography, physics, or geography, mathematics. So total geography students are 23. Out of that, physics studying students are 3. Since it's OR, so plus mathematics are 5, which are students studying mathematics and as geography. So 5 upon 23. So we add them up. Since the LCM will not be taken out, denominator is same. 5 plus 3, 8 upon 23. Question number 22. The probability of picking a red sweet from a bag is 0.05. Find the probability of not picking a red sweet. So probability of not picking a red sweet is 1 minus 0.05, which is equals to 0.95. Clear? Question number 23. A bag contains 5 red balls, 4 blue balls, and 3 green balls. 5 red, 4 blue, and 3 green. Megan picks a ball at random. Write down the probability that the ball is red or blue. So probability of red plus probability of blue. Probability of red is 5 upon total are 5 plus 4, 9, 9 plus 3, 12, plus probability of blue is 4 upon 12. So simply 5 plus 4, 9 upon 12 is the answer. Clear? Okay, Megan replaces the ball. She picks a ball at random, notes the color, and replaces the ball. She repeats this 60 times. Calculate the number of times the ball is expected to be red or blue. We know the probability of red or blue. So we have 9 upon 12. Multiply by how many times she is doing this experiment? 60 times. So 9 upon 12 multiplied by 60. 12 ones are 5, 12 5s are 60, 9 5s are 45. Clear? Meg picks 2 of the 12 balls at random without replacement. 2 of the 12 balls. Calculate the probability that the balls are of different colors. So how many different colors, different combinations can be made? Without replacement means that the person is picking one, he's not putting it back, picking the other one, right, in one way. So it can be R red blue and blue red, so twice. It can be blue green, green blue twice. It can be red green or green red twice. Okay, so probability and probability. Okay, so red is 5 upon 12 multiplied by blue is 4 upon, not replacement means the remaining balls will be 11. Same will be everywhere. So probability of blue is 4 upon 12 multiplied by green is 3 upon 11 plus 2 red is 5 upon 12 and green is 3 upon 11. Now simplifying this to get the final answer, 4 ones are 4, 4 threes are 12, 4 ones are 4, 4 threes are 12, and 3 ones are 3, 3 fours are 12, 4 2 ones are 2, 2 twos are 4. Okay, 3 3 cancels. Okay. Now simplifying it over here, as we are having less space. So 2 5s are 10, 10 upon 3 11s are 33. So 10 upon 33 plus 2 ones are 2, 2 upon 11 plus 5 upon 5 ones are 5 and 2 11s are 22. Right, now taking LCM, if I take LCM of these three terms, I'll get 66. Right, let me show you the LCM as well. 11, 22 and 33. So 2 11s are 22, 33 remains same, 11s remain same, 3 11s are 33, 11 11. So 11 1 1 1, 2 3s are 6 and 6 11s are 66. So 33 into 2 66, 2 tens are 20, 11 6 are 66, 6 2s are 12, 22 3 are 66, 3 5s are 15. So 20 plus 12 32, 32 plus 15 is 47. So 47 upon 66 is the probability that the ball are of different colors. Clear? Okay, let's erase them up. Okay, now Mary picks balls at random without replacement from the 12 balls. When she picks a green ball, she stops. The probability that she picks a green ball on pick n is 21 upon 220. Now here we cannot decide that on which pick she will be getting 21 upon 220. And since it's a big answer, we can assume to be 4th or 5th. Let me start with the 4th pick. The first pick is not green. It means that how many balls are there? 9 5 5 plus 4 9. The other color balls. So 9 upon 12 is the first pick. Multiply by 8 upon second pick, 11, without replacement, right? Multiply by 7 upon 10. Now this is first pick, this is second pick, this is third pick, and fourth pick is from, I'm assuming it to be the fourth pick on which he is getting green. So 3 upon 9. Now if I simplify this, 9 into 8 into 7 into 9 into 8 into 7 into 3, I'm getting 1512. And in the denominator, 12 into 11 into 10 into 9, I'm getting 11880. 11880. If I simplify this up using my calculator, what I'm getting is 1512 upon 11880, right? 1512 upon 11880. I'm getting 7 upon 55. No, that is not the probability which we have in here. Okay, so fourth, no, we will try for the fifth one now. So the fourth one again is a non-green ball. So that is 6 upon 9. Multiply by now green ball 3 upon 8. Let me simplify this. 9 into 8 into 7 into 6 into 3. That is 9072. Okay. And 12 into 11 into 10 into 9 into 8 is, should we use 8? Yes. So 95040. 95040. 95040. And if I simplify it, I'm getting in calculator 21 upon 220, which is the required probability of here. So this came in the fifth pick, right? This is called trial and error, which we did to simplify this question, right? So fifth is the answer. Clear? Question number 24. Katie picks a number at random from the numbers 2, 3, 5. She then picks at random from the numbers 5, 6, 7, 9. When she adds the two numbers, the answer is even. Find the probability that exactly one of the numbers picked is a 5. So how many combinations can be there for even? 2, 6. Okay, 2 plus 6, 8. 2, 7 will be 9. No, 2, 9, no. 3, 5, yes. 3, 5 plus 5, 8. 3 plus 6, 9, no. 3, 7, 3 plus 7, 10. Okay. 3, 9, yes. 3 plus 9, 12. Now combinations with 5. So 5, 5, 10. Okay. 5, not with 6, 11. 5 plus 7, 12. Okay. And 5 plus 9, okay, 14. Okay. Clear? So these are the combinations which I have got when I'm combining two numbers having an even result, right? When we are adding them up. So now find the probability that exactly one of the numbers picked is a 5. So how many exactly? We cannot have two. Exactly means one number should be 5. So that is a combination of 59, 57 and 59 and 35. So out of 7 we have 3 and total are 7. So 3 upon 7 is the probability. A spinner can land on the colors green, black and red or red. The table shows the probability of the spinner landing on green or black. On green or black. Okay, we are given these probabilities. Calculate the red one. So adding again the same concept, the total is 1, right? Now solving this fractions, 20 is LCM, 5 4s are, 4 2s are 8, 4 5s are, 5 1s are 5, plus x is equals to 1. So x is equals to 1 minus 8 plus 5, 13 upon 20, which is equals to 7 upon 20. Clear? So the completing the table is done. Chang spins the spinner 120 times. Find the expected number of times it lands on green. So we have the probability of green multiplied by total number of times he is doing this experiment, right? So 5 1s are 5, 5 2s are 10 and 5 4s are 20, 24 2s are 48 times the expected number it will be landing on green. Okay, question number 26. Eric has 4 colors of paint. The table shows the probability that he uses each color. 0.3, 0.35, 0.3 and x. Okay, again adding this up. 0.3 plus 0.35 plus 0.13 plus x is equals to 1. Okay, so 0.3 plus 0.35 plus 0.13 is 0.78. So x is equals to 1 minus 0.78. I add these all up and I shifted the total over here. So 1 minus 0.78. So it is equals to 0.22. Clear? Okay, question number 27. A bag contains 5 green buttons, 2 blue buttons and 6 white buttons. Maya takes 2 buttons at random from the bag without replacement. Calculate the probability that one button is green and the other button is not green. So one should be green. So combination of green, blue and again blue, green. The combination of green, white, again white, green. There can be no other combination. Because if I make blue, blue, it's not one green. If I make green, green, again both button cannot be green. So two combinations. Okay, applying the probabilities. Green probability is 5 upon. The total is 5 plus 2, 7. 7 plus 6, 13. Blue probability is 2 upon without replacement. Without replacement means that one will be less, 12. Plus 2. Green probability is 5 upon 13 multiplied by white is 6 upon 12. Okay, now 2 ones are 6, 2 6 are 12, 2 ones are 2, 2 3s are 6. Okay, 6 ones are 2, 6 1 6, 6 2s are 12 and 2 2 cancels. What we are having here, 1, 5 ones are 5, 5 upon 39. plus 5 ones are 5, 5 upon 13. Okay, 13, 39 LCM is 13, 39 is 3 ones are 3, 3 threes are 9, 13, and 13, 1, 1. So 3 13s are 39. So 39, 39, 5 ones are 5, 13 threes are, so 3 fives are 15. So 5 plus 15 is 20, 20 upon 39 is the answer of question number 27. Is it clear? I hope everybody is understanding each question, right? Okay, question number 28. A spinner is spun and we have the probabilities, all probabilities. Complete the table. Again, the similar question, 0.2 plus 0.05 plus 0.35 plus x is equals to 1. 0.05 plus 0.35 is 0.40. 0.40 plus 0.2 is 0.6 plus x is equals to 1. And x is equals to 1 minus 0.6, which is equals to 0.40. So 0.40. Clear? Question number 29. Bag A and bag B each contain red sweets and yellow sweets. Anna picks a sweet at random from bag A and Ben picks a sweet at random from bag B. Okay. The probability that Anna picks a red sweet is 2 upon 5. The probability Anna and Ben both pick a yellow sweet is 1 upon 10. Find the probability that Anna and Ben both pick a red sweet. So we want to find out the probability of Anna picking red sweet multiply by Anna and Ben both, sorry. Anna and Ben both, right? Anna and Ben red sweet. Since Anna and, right? So multiply by probability of Anna and Ben both pick a red sweet. Yes, okay. So now to calculate this, probability that Anna and Ben both picking a red sweet, we want to know that what is the probability that Anna pick a red sweet and what is the probability of Ben pick a red sweet. We want to know both of them, right? So we have the probability of Anna picking a red sweet, that is 2 upon 5. But we don't have the probability of Ben picking a red sweet. So to calculate this, I should know the probability of Ben picking a yellow sweet. So to find out this, I will use this information which is given over here, 1 upon 10. So, and for that I want to know that what is the probability that Anna will pick a yellow sweet. So first one is to find out the probability of Anna picking a yellow sweet, which is equals to 1 minus 2 upon 5. Because we have red sweets and yellow sweets, only two possibilities. 1 minus 2 upon 5 will be 3 upon 5, right? That is the probability of Anna picking a yellow sweet. Okay. Now I want to find out the Ben picking a yellow sweet, right? That will be 3 upon 5 multiplied by x is equals to 1 upon 10. This x is basically probability of Ben picking a yellow sweet. So 10 will go over there. 10 into 3 upon 5. 10 will go over there, right? No, sorry. 10 will be coming over here. Sorry. So 10 multiplied by 5 upon 3. So 10 fives are 10. Sorry, I'm sorry. A mistake over here. This was 1 upon 10. Right? So actually the 1 upon 10 stays over here, 5 over there, 3 stays over here. So 5 will shift over here and 3 will go over there. So 5 upon 3. Okay. So this will be 5 ones are 5, 5 twos are 10. This will be 1 upon 6. So 1 upon 6 is the probability that Ben picking a yellow sweet. Is it clear? So we now know that the Anna picking a red sweet is 2 upon 5. Anna picking a yellow sweet is 3 upon 5. Ben picking a yellow sweet is 1 upon 6. So Ben picking a red sweet, I want to find out. So Ben picking a red sweet is equals to 1 minus 1 upon 6, which is equals to 6 minus 6, 6 minus 1, 5 upon 6. So now I know that Ben picking a red sweet is 5 upon 6, Anna picking a red sweet is 2 upon 5. So putting these values, probability of Anna and Ben picking a red sweet. Anna and Ben red sweet is equals to 5 upon 6 multiplied by red sweet 2 upon 5. 5 cancels, 2 1s are 2, 2 3 is 6, 2 1 upon 3. Clear? A little bit tensed. So actually there was a vision problem, what I noticed. So first we took out, I'm repeating this question again. We have the probability Anna picking a red sweet. We have the probability that Anna and Ben both pick a yellow sweet. We also find out the probability that Anna and Ben both picking a red sweet. So to find those, just I should know then Anna picking a red sweet, I know, but Ben picking a red sweet, I don't know. So the whole working is for Ben picking a red sweet. That came out to be 5 upon 6. Clear? Okay. Question number 30 is, over here we have the probability of 4 events and complete the table. So simply 0.3 plus 0.16 plus 0.18 plus 0.25 plus x is equals to 1. Right? So 0.3 plus 0.16 is 0.46. Right? And 0.46 plus 0.18 plus 0.25. 0.3 plus 0.16 plus 0.18 plus 0.25 is 0.89. Right? So x is equals to 1 minus 0.89, which is equals to 0.11. Clear? Then spinner once, find the probability that the spinner lands on red or blue. So red or blue means that we should know the probability of red or blue. So red or blue, probability of red is 0.3, probability of blue is, probability of red is 0.3 and probability of blue is 0.16. So 0.46, right? 0.46 is the probability of red or blue. Okay, now find out spinner once, find the probability that the spinner lands on red and blue. Clear? So probability of red or blue is adding both probabilities simply. When we have the OR condition, we just add the probabilities, and when we have AND condition, we multiply the probabilities that we did over here as well in the previous question. Clear? Okay, let's do the question number 31. We have completed the table. So 0.4 plus 0.32 plus 0.17 plus x is equals to 1. So if I total them up, I will be getting 0.4 plus 0.32 plus 0.17. That is 0.89 plus x is equals to 1. So x is equals to 0.11. Clear? There are 1800 students at the school. Find the expected number of students that walk to school. So probability of walking is 0.32 and the students 1800. So simply 0.32 multiplied by 1800 is 576. That is the expected number of students that walk to school. Is it clear? I hope you enjoyed this whole video and the questions were well understood, and I hope a better version as well in future. So I would like to request again that kindly support our cause in this. Jazakallahu khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.